This video shows my evolution of the great mini skiddy designs by Professor Boots. He's come out with 3 iterations of the mini skiddy, versions 1, 2, and 3. I built version 2 and modified it a fair bit for my own use. It was mostly a wheeled design and used a small printed circuit board which powered all the motors from 5 volts. It used LiPo batteries, 2S, so they're about a 7.5 to 8 volt battery, and they lasted pretty well, but LiPos are a fire hazard. So in version 3 he came out with a different printed circuit board which you can get, which use a little safer. These are from Phoenix and these are 1S. You can have 2 of these, and these just recharge using a USB-C. So after building a track version based on his version 3, I evolved that design to what you see here with the PS3 controllers, and these are very cheap. You can get these at AliExpress for about $8 Canadian, probably $6 US. They work really well, and you can pair them with the right software with your mini skiddy, your ESP32, to go forward, backwards. So this is sort of the final evolution. We've got some flasher lights. We've got a light bar in the front as well. But what was nice about this design is it used a proportional throttle. And you can see I can vary the speed. And this one still goes fairly straight, and I'll show you what designs changes I used to do that. I'm going to release the full STLs and step files, so anyone that wants to play around with this design, you're free to do that. I'll try to give you all the documentation on how I hooked up the lights, all the parts that I might have modified slightly as well. So my first iteration of this was here, and all my designs are based on the version 2 board, but I do make one change with the board. I cut one trace and add a barnacle. This board is not modified. And if you just add one wire as a modification, you can get the full battery power to power all your motors. So very easy modification to do. So we'll look at this older design. One of the problems with track designs is that there's inherently can be a lot more resistance with the tracks rather than the wheels. And I wanted to try to get a proportional throttle, and we'll just pair this here. Just press the button and one light should come on. Now it's paired with this skiddy. And so I can go full speed, and you'll notice this is a little faster than the other one, and that's because this is using about 12 volts, 140 RPM. The other is using 100 RPM, so this is about 15% faster. It's not straight, and that's because there's more resistance on one side than the other. If I try to use a proportional throttle, which means I'm going to only give it enough voltage as far as the joystick goes, it'll whine a little, and you'll notice that one side may not even start turning before the other side starts turning, and it will turn. So it's hard to control when going slow. But generally with the release software, you're giving this full power, which is fairly good. But for the do-it-yourselfers, you may have different motors which are slightly mismatched. So the drive system of this looks a little different. These represent the walls, and this is the unpowered hub. And what we have here is we have a bearing here with a 5mm opening. I use an M5 screw here. I have a lock nut on the hub, and we would simply screw this into the lock nut. Now obviously it won't turn there, so we back it off just enough, and that will spin with very little resistance. So that's the unpowered hub. In the powered one, we have the motors going right up to the wall. Because they go right up to the wall, I probably have enough room for the N30 style motors, which are only 4 or 5 millimeters longer. This will just push on. There's another bearing right here, which is about a 7 millimeter wide bearing with a 3 millimeter gap. It's a little different bearing. So this has a D shape as well, so it goes on to the shaft, but it's a small shaft. So what we also have here is a place for a grub screw. So I use an M3 5 millimeter, and if you put a grub screw, that will screw down into the flat part and make it a little better, more solid. So those are the two drive modules here. And the advantage, I think, it has more consistent resistance. So I can go, that's full speed, a little slower because they're only 100 RPM motors. But if I go slow, you'll know it's still fairly straight. We don't have one motor overbearing the other. I can turn at full speed, but I can also turn slightly if I want to, which gives me a little more precision. Now there's some other advantages to this design that I made. I made a backup flasher. Whenever I go in backup, that flashes. And you'll notice I have a light bar. Now they're both working off the aux motor, and I'll show that in the details. I'm going to publish this on Printables, but I'll have all the documentation to show how to build this. If I go backwards, there is a priority. The backup flasher, well, for safety, will take priority over the lights. And that's the nice thing about being able to modify the software. Now this arm, actually I had a problem with arms. The motors I was getting from AliExpress weren't really powerful. I don't know if that's indicative of all the N20 motors. What you'll notice is that there's this brass gear section here. I did find some 6-volt 15 RPM motors in which this was longer. It had another section, so the brass section was about 12 millimeters. Most of these N20 have a 9 millimeter gearing system here. For these 9 millimeter ones, I found that with the claw, I had a hard time lifting the arm properly. And now it seems hard to find the 6-volt 15 RPM motors that I order are no longer coming with the higher torque 12 millimeter gear section here. So what I did was I switched to an N30 motor, but the only N30 motor I had was about a 55 RPM, which I think is a little quick. So I've ordered some other ones, but it's nice that this can take a N30 motor, and then there's lots of power to put this up and down. So let's look at some of the changes I made here. With this section, I made a narrower track. If you compare the original track here, I think this is 24 millimeters and my track is 20 millimeters. Just cuts down a little bit, not only on the grip, but on the friction. We'll take the cover off and take a look underneath. This is the underneath section. I have a flasher. These are all just white LEDs. So I have 4 of them. I flash this in software. I use a transparent PETG filament just to make this flasher case to make it red. And I connect everything with these JST 2-pin connectors, which I find a little easier for maintenance when I'm taking things on and off. And I did that for all the motors as well. I had some issues with being able to reliably, I don't know if you can see them here, but connecting into the connectors which normally go here. I was getting fairly cheap connectors from AliExpress, and some were very reliable, and some I found that they were difficult. The wires would come out. So I decided to solder all the wires in and put all the motors on connectors. I'm hoping it will make them also a little easier to change if a motor breaks. So the inside has been changed a fair bit. And you can see that the motors go right up against the right here. And there's a little more room inside than I had in my original remixes of this housing. But inside on the floor there, this housing should support the version 3 of the printed circuit board. So you could use hopefully the version 2 or the version 3. I modified the claw a little bit. I have a little bigger cutout here to accommodate the wire. Bucket has these round bits right at the end, and that's because as I was going under something, they would get stuck, and if I lifted up, the motor would stall. So this round part prevents them from sort of getting caught under a wall. Now, one other thing I found that I burned out a few of these claw servos. Here we'll pick up a foam basketball. Now what you can see here is that this is squeezing the foam basketball, and what will happen is this servo is actually trying to close this. So it's trying to get to a position down here. This little servo will get very, very hot because the motor inside it is trying to make this servo go to here. But the foam basketball is preventing it, and you can see a little indent here as it's applying some pressure. So what will happen is if you leave it in that position too long, the servo will just overheat and it will burn out and you'll need to replace your servo. And you can see that by, if I leave this out and let it go, you can see that that closed further. But this didn't change, and that is because I made this part here out of TPU. So this is the original, the same shape, it's just solid TPU, basically 100% infill. And I found that's helped fairly, that's improved things quite a bit. It doesn't open and close quite as smoothly, but you can see that if I hold that the servo can go. It doesn't bind up. So that has allowed this servo to last a little longer. So those are some of the improvements that'll be posted on Printables. It is a work in progress. I'll be updating this as I find some improvements in my design. The original design is wonderful, and these designs that I found that had too much friction were mostly because of my own modifications I made to the original designs. They weren't inherent in anything that come with the kits or whatever. But this is just for those do-it-yourselfers that want to build everything or try different things, try proportional throttles. I'll post all my design and the code and explanations of it all.